What's going on, everyone? Steven here, back with a new cheat engine video for you. Today is a good day. Cheat Engine 6.8 has been released and has a bunch of cool new features in it. But one of the things for beginners is a new tutorial. So we have the two original tutorials, one being the 32-bit, one being the 64-bit. Same thing in terms of the content. But now we have this third one, which is more games based. So it's 3 mini games. And so we're going to quickly hash our way through that, or I'll run through it, my own way, and then you can run through it and solve it your own way. So I'm going to go ahead and open the process here with Cheat Engine. So for this first tutorial, it says we have 5 shots, and after those shots it'll reload. The target also heals after those shots, so we need to find a way to destroy the target. So we have a couple of things here. We have our ammo, we have the enemy health, which presumably we could look for enemy health as it decreases, right? By doing initially an unknown initial value scan. Try to find that. I'm going to fire the last shot here and see what happens. Okay, it's replenishing, and here our ammo is replenished. Or we could look for ammo. I'm going to look for ammo, so the first thing that we could do is type in 5, first scan, fire a shot, type in 4, next scan, alright, fire a shot, and these did not change, so that's not it, alright. So that could mean maybe the value is a float, it could mean the value is encrypted, it could mean the value we see here is a string and there's something else going on that we need to check out. Or, since we know that going from 5 to 4 to 3, that's a decreased value scan, essentially. We were looking for exact values, but if we were looking for a decreased value scan, we should have seen that. So, maybe it means that there's actually a value in a memory address that's increasing with every shot until it resets. Okay, and then that value gets interpreted as what we see here on the screen. So I'm going to fire my last shots there. I'm going to do a new scan. Alright, this might be a mechanism of like, every time you fire a shot, 1 is added. So let's say this value is maybe 0, or we could start with an unknown initial value. I'm going to do first scan of 0, fire a shot, say 1, fire a shot, say 2. Alright, and here we go. So we could have just done unknown initial value scan, and then we could have done an increased value with each shot until ammo reloaded. Then we would do a decreased, because I'm going to bring this down and show you what happens. We fire a third shot, we fire a fourth shot, then when we fire the fifth shot, it resets. Okay? So 0 when we haven't fired at all, 1 when we fired once, twice, 3 times, 4 times, and then it resets. Alright? So, this would be the same thing as starting with unknown and then doing increased until it resets, and then we go decreased, and then we start increased again as we count up to 4. Right? So now what we could do is let's just try locking the value and seeing what happens. There, we could fire as much as we wanted. Alright, and we're done with that. Cool deal. Alright, so step 2, these two enemies have more health and do more damage to you than you do to them. Destroy them. Enemy and player are related. That means shared instruction. Click to hide. We'll do that. Alright, so now we could move around if we wanted to. We see player health is 100. I'm going to shoot an enemy and see what they do. Alright, they fire back at me. My shot took off basically no health from them, but I took damage here. So I'm going to look for my health. 9-6. New scan, first scan. Alright, fire another shot. My health is down to 92. Alright, here we have this. Let's try locking it and see what happens. Alright, it's staying there. So now we could kill one of these guys and see what happens. This is something quirky that I found. You see how, slow it is killing this guy? If I go over here, the other enemy projectiles will count as damage against him too. So that's, I guess you could call that a bug. Alright, so you will pay for this. Activating mega bombs. What does that mean? I'm going to fire a shot at this guy. Okay. It's a homing missile, basically. Alright, and if it hits us, what happens? Alright, our health is -1. Alright. Alright, so there it restarted. So just locking the value didn't do what we wanted to do. Let's fire a shot. Alright, our health 88, it appears to be the same memory address, so let's go find out what writes to this address. Alright, and let's get shot. So this sub instruction. So let's go show disassembler. Okay, and we have this sub instruction. And let's go, we're going to stop that. Actually, we can go ahead and close that. I'm going to go find what addresses this instruction accesses, because we want to find the other addresses that this instruction does something with. So I'm not going to shoot them yet. I'm going to get shot and watch my address pop up here, okay, with my health. Now I'm going to shoot one of them. Move out of the way. Alright, that's that guy's health in that address, and I'm going to do that one last. Oops, I accidentally hit the other guy that I already hit. Alright, there we go. So now we have all three addresses. So now we have a couple of things that we can do here. I'm going to show you a couple of scripts. The traditional way is going to be to do a structure and data dissect. We'll start with that. So let's select all of these and let's right click and go open dissect data with selected addresses. And just click OK through all the generic stuff here. Alright, so since this is RAX plus 60, offset 60, that's what these addresses are. You know, whatever is in RAX plus 60, that's these memory addresses. Okay. So whenever we do the data slash structure dissect tool from this particular window, it will start at the base. So our addresses here are actually going to be at offset 60, because this is base plus offset 60. Okay? And here we do see that it is health for us and then the enemies. So now what you could do is place the enemies into their own group. So you can click up in this area here, hit Control G for a new group. Click in here, Control A to add a new space for an address. We're going to copy the two enemy addresses and put them over here. And then I'm going to delete from these, or delete those two from this group. So in this group is player, in this group are the enemies. And that just gives us different colors here that we can look at in the window here. So we can see here that this purple color is something where this group has a value in common, and that common value is different from this group. So that's a good differentiator for us. Because this is health, and these values are what they are, this looks like max health, and these look like current health. But if you look down here, there's a value of 0 for the player, and then a value of 1 for the enemies. So, you know, it's looking good that we have a couple of things that we could base a script on. So the first thing that I'm going to do is, because it takes so friggin' long to kill the enemies, we want to create a one-hit kill script. Alright? So I'm going to use this offset, 64. I'm going to stop that. Since we need 5 bytes at least for a jump, instead of starting the jump on the sub instruction, which would be 1, 2, 3, 4, 5 bytes, which in the middle of that there's a ret, I like to avoid having my code injections come across a ret if at all possible. So instead of basing it on the sub instruction, I'm going to move up one to this move instruction. So we'll go Tools, Auto Assemble, Template AOB Injection. We'll say OK. Well, actually, let's copy this first because I'm going to show you something else you can do. Copy, OK. Just click OK here. Instead of doing the AOB scan, which is a little more processor intensive, what we can do is comment that line out, and we can say define, and then just use the same label that we use, the same name here, and then put that there. Because the way the AOB scan works is it will look in this module for this exact group of bytes, and then whatever memory address it finds the start of however many of this group of bytes in, it will reference that memory address here like as this label. We give it a label. So basically, instead of G tutorial dash blah 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 plus 3EE50, Cheat Engine knows that at inject, right, which would be here, it will jump to new mem, which is our new memory that we allocate for our code injection, right? So long story short, with this define, we're saying at this memory address, go ahead and apply that, label for use in our script here, essentially, or symbol. You can think of it as a symbol. So yeah, typically if you have module plus offset, you can substitute that, and it can be just a nice quick little way to do that. So anyway, since we know that offset 6.4 is max health and 6.0 is current health, right? You could either write a script that's going to put max health into EDX here, and then it would subtract that max health from current health. We could just use that original instruction in a manner like that. Or what we'll do is, we'll use these values for our compare, okay? And then we'll just like move 0 into there here instead of doing the sub, right? So the first thing that we'll do is we'll push F because we want to do a compare. So we're pushing the flags register onto the stack to preserve, okay? And now we're going to say compare RAX plus 6.4, because that's this offset with these values here, to number 100, which means decimal 100 instead of hexadecimal 100, which is a completely different number. All right. So we're going to compare that. Okay. Let's see. If it's, what do we want to do? Jump if equal to at forward. We'll do anonymous labels here. Okay. So we'll say at that. All right. So what this means is, well, I'll finish writing this and then I'll explain what anonymous labels are and all that. So if it's 100, we're going to jump to this label, to this anonymous label, where we will pop F. We'll pop our flags register values off of the stack back into the flags register. Okay. If it's not equal, which means it's the enemy, we're going to move, we'll just comment out this instruction. So by not including, well, actually, before I explain that, I'll just go ahead and do what I'm going to do. Move into RAX plus 6.0, 0. All right. Yeah, so here's what happens now. Our code injection comes in, it runs this, which we need. We let that happen. Push the flags register onto the stack. We compare this offset, the address here, whatever is in there, to 100, because we're looking for the player. Is it the player? Okay. If it is the player, then we're going to jump to this anonymous label. So with anonymous labels, you have at B and at F, and then you have at, and then at. So at B means, whatever condition you have being satisfied or not. If you're going to jump at B, you're going to go to the anonymous label, the first one that it sees, back up the instructions. So if I had at B here and I had an anonymous label here, all right, jump if equal at B, it will jump back to here and then presumably run all this stuff again. If we jump at F, that's going to look for an anonymous label forward in execution. So jump if equal at F, it'll look for an anonymous label forward. So at B back, at F forward. All right. This is basically a quick way to give yourself sort of a forward engineering logic approach in assembly while using Cheat Engine's auto assembler. So yeah, that's what we've done. So if it's the player, we're going to jump here and we're just going to pop that value off the stack back into the flags register, and then we're going to jump to return. So the sub instruction will never run. So if we get hit, it shouldn't do any damage to us. However, if it's the enemy, we're going to move 0 into health. So it should be a one-hit kill for enemies. So we've got a double whammy here. We've made ourselves invincible and given ourselves a one-hit kill for enemies. So I will assign that to current cheat table. Close that, come back in here. I'm going to enable this. All right, and let's see what happens when I get shot. All right, see how my health isn't decreasing at all? All right, I'm going to kill this one enemy and see what happens. Boom, we got our one-hit kill. Cool. You will pay for this activating mega bombs. Let's see if it kills us or not. Nope. So we are truly invincible. All right. So let me just kill this last one here. So there are plenty of other ways that you could go about doing that one right there. But anyway, so cool. We're done with that one. All right. Mark all platforms green to unlock the door. Beware enemies are one-hit kill. Have fun. There are multiple solutions, e.g. find collision detect with enemies, or teleport, or fly, or ... We're going to do ... Alright, so let's see what happens here. We jump around with this dude. One-hit kills, indeed. So we jump around with our guy. We need to activate all these platforms. So if we do that, let's see if I can get over there. Nope. Anyway. So first of all, what's going on here? Okay, we need to activate all these platforms for this door to unlock. So that means presumably there's a value that's going to be counting up in memory as we activate each of these platforms, right? And then once a certain condition is met, something happens. So what we can do is try to search for that value in memory. So I'm going to go ahead and die. All right, do a new scan, and we could say unknown initial value. Okay, let's jump on a platform, and let's look for a changed value. And now unchanged a bunch of times. All right, see how many values are being removed there in the found list. So, okay, now I'm going to activate another one there and do changed. And now unchanged. Let's activate one more. Changed. Unchanged. All right, look at that. So look at this 4 here. All right, these are big numbers, may be relevant. This 0 might be, but this 4, well, now we know it's not because that one just changed. But anyway, 4. What could this 4 correlate to? Let's watch that value. Look at these changed ones. We know those aren't going to be it. Let's unlock another platform here. That went up to 5, 6, 7, 8, 9, 10, 11, 12 if we do these other platforms. So let's bring this down here and let's change this to 12 and see what happens. Alright, the door unlocked, but all these dudes are now keeping us from going in the door. Right, so it looks like we found something relevant. So let's see, can we get in here? Okay, so we died. So how do we actually beat this level now? Alright, I'll show you what I did. So you might be wondering why this value is 1 already by default. And that's because the platform here that you're standing on is green, right? So one of these things already is green. So what we want to do is we can find out what accesses this address. All right. So this is an instruction that's reading the value from here. Okay. So we'll stop that. We'll go show disassembler. And here is where we are. However, if you look around in code, a little farther down, we see well done. Well done. All right, well, we know that that's the message whenever we succeed. So, we can look at these lines here and see that there are all these jumps that, depending on various conditions, everything ends up coming back to this compare. But if we make it through this jump, we get to this move instruction, and then we've got a load effective address, where in this address there's this string well done. What happens if we could just come into here, if we just jump here? Well, since we see through execution, we're definitely going to hit this jump. This compare will happen, and then, excuse me, we'll make it to here, and the jump will happen or it won't, whatever. But we know we're going to get to this instruction regardless. And we could test that by right-clicking and saying break and trace instructions. Just say OK, and here we see that the break trace was triggered, right? So what if, instead of this jumping if equal to module plus offset 401C4, okay, what if we jump? So always jump to, let's do this, V, jump, all right, to 40, let's see, well done is here. So this move is where we want to go to, 401AC. 401AC. If we change it to that, what happens? Well done. You have beaten all 3 games. Well done. So, yeah, we just bypassed whatever logic it has going on for unlocking this door or all the enemies flying to the door. So presumably we would want to make it to where the enemies don't fly to the door, or we find the mechanism that's keeping the door from being unlocked and we just knob a jump or something that will unlock the door. Right, there's a bunch of different things that you could do. So anyway, these are just the ways that I decided to attack these 3 games. So I encourage you to hop in yourself, check them out. Feel free to share your solutions in the comments for others who are interested. I'd love to see what others of you come up with. So just a nice little fun refresher tutorial there for Cheat Engine. So anyway, thanks for watching. Give me a thumbs up if you enjoyed it. Don't forget to subscribe, especially if you're new. If you're new around here, then go check out other videos of mine. I have a ton of game hacking tutorials and whatnot. So anyway, thanks again, and I'll talk to you all in the next video. Take care.